Now we will see the second case. The second case is E equal to 2 by 3. Obviously you see this 2 by 3 is less than 1. When it is less than 1, it will give a curve of ellipse. The same methodology we can implement for this. First, a line, vertical line, you can draw. This is A, B. And perpendicular to this, a horizontal line you can draw. Right. Now mark this as D, and here to here, that is 65 mm. At 65 mm, DF equal to 65 mm. DF equal to 65 mm. Right. Now we want to consider a point 2 units towards the F, 3 units towards the D. Then only that VF, suppose if you give this as V, VF by VD is equal to 2 by 3. Okay. Now you tell me how many divisions we required. That is equal to 5. Okay. The 65 mm you need to divide into 5 equal divisions. That 5 equal divisions are nothing but, that means each division is 13. Okay. Now 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay. Now 1 and 2. After considering 2 divisions, here we need to consider V. Okay. Now VF by DV is 2 by 3. Okay. Now as usual, draw a perpendicular line at V, and V as center, VF as radius, draw an arc. It will cut here at V1. Right. Now D and V1, consider these 2 points. Draw a line. Here also we can call this line as a proportionate line. Okay. And the V1 to VD, that is equal to, here also you can write, this is equal to V1 divided by DV. That is also equal to 2 by 3. And now you can consider number of perpendicular line to DF. Right. Okay. Now I consider like this, and I will give the numbering. This is 1, 2, 3 and 4. Perspective line 1 dash, 2 dash, 3 dash and 4 dash. Now as usual, 1 dash as radius, F as center, draw arcs on either sides of the 1 dash line. Okay. After that, 2 dash as radius, F as center, draw the arcs on either sides. Right. Next, 3 dash as radius, F as center, draw the arcs on either sides. 4 dash as radius and F as center, draw the arcs on either sides. Now if you draw a smooth curve through this curve will be a open curve here, but we know the ellipse is a closed curve. Okay. Where it will close? It closes at the other end of the major axis. Okay. And if you consider another line and consider that as radius and F as center, if you draw it, it will give a closed curve like this. Okay. And where it will close exactly, we cannot know by using directly this methodology. Okay, but by using some mathematical interpretation or mathematical considerations, we can find the other end point. Okay, for that I will show a small observation. Suppose this is the ellipse, okay, and this is the major axis, right, and this is directrix, and this is proportionate line, this is way, right. Now a line, perpendicular line, if we draw like this, these two will cut at this point, right. Okay, now if you take this as radius, F as center, if you draw arc on this line, that arc will obtain here only, then only that will be other end. Okay, that means we take this length and we draw the arc from F, okay, and it will cut here, this line length equal this line length, okay, and here the angle is 90 degrees. Therefore, from F, this line hypotenuse, if you draw, that hypotenuse will be at 45 degrees. At 45 degrees. Okay. This methodology we can use to find the other end point. It gives a smooth and a better curve for the ellipse. Now we will go. See, draw a 45 degrees line from here. From F, a 45 degrees line. Draw this line. Okay. And this is equal to 45. And we got an intersecting point here. And draw a perpendicular line to axis. Right? Now, this is the end point. If you take this length and F as center, if you draw it, this is other end, V dash, V dash, right. And in between this, you can consider some vertical lines to obtain the more points, okay. Then, if you take 5 dash, 6 dash, okay, 5 dash as radius, F as center. If you draw it, it will gives the intersecting point here and here. Next, 6 dash as center. If you draw, it will gives here. And V dash and V1 dash as radius, F as center. If you consider and if you draw arc, it will give here. Now we can draw a smooth curve through all these points. I have not drawn with the exact scaling. That curve slightly deviated. That is the reason. Just I want to readjust. And the smooth curve will be like this. Okay, if you take exact dimensions, it will give exact elliptical shape. Okay, this is the methodology we can adapt for drawing of ellipse. Okay, this is the eccentricity method or general method. Here also, to draw tangent and normal, the same methodology we can implement. Suppose from F, consider 55 mm and mark P, and P to F, draw a line and perpendicular line to the that PF line, right? It will cut the directrix here and draw a line like this and extend it. Just it will touch the ellipse at P point. Then it will called as tangent, T dash. Okay, if you draw a perpendicular line to this will give normal N dash. Okay, this is the ellipse. Okay, we need to mention ellipse. Ellipse. Right. Okay, now we will go for the third case.